All right, so this is our last day for review and everything. So we've dealt with pretty much everything from the class. But today I just want to go ahead and go back to some more statistical probability stuff, and then go back to like a right triangle thing too. And that way we can go ahead and get all the stuff that we've learned this semester in here somewhere in a review. So this is the last portion of it. So let's get this and let's hit it. Let's go. All right, so looking at these, we're talking about again different types of problems here. The first one says, suppose heights of 9-year-old girls are normally distributed with a mean of 52 inches and a standard deviation of 2 inches. What percent of 9-year-old girls are between 50 and 54 inches tall? All right, so with that, again, we know we're talking about, okay, standard deviation, we're talking about mean, and they use the words normally distributed, which means that we're talking about a bell-shaped curve. We're talking about this right here. So the mean is right there in the middle. There we go. The mean is right there, the mu. And then we're talking about 1 standard deviation, 2, and 3 standard deviations. And they're negative on this side, positive on the other side, blah, 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 blah. If it would stop erasing, that'd be great. Oh, it's erasing again. Stop it. I don't know why it's erasing. So, but that's 1. What? Okay, so it should be 1 here, 2, and 3. Let's see if this is doing something. All right, so I'm not sure why that's happening, but guys, it's happening. And then we have 2, so let's see if I can move it over. Yep, there we go. It's 2 here, 1 here. All right, so we have the positive, we have the negatives. So, yeah. So with that, as we go on, we're trying to find, okay, the range between 50 and 40. So here we know our mu, our mean, is 52. We know our standard deviation is 2. And so just like we did before, we had to find those numbers. So remember, we did things like this. It's not letting me write today. There we go. Mu minus 1 standard deviation, mu minus 2 standard deviations, mu minus 3, so on and so forth. And then we did the addition ones also. So mu plus 3 standard deviations, plus 2, and plus 1. And we substitute the number for mu, we substitute the number for standard deviation, and then we worked it out. So here, if we put, I'm just going to do 1, so that way we can go ahead and just keep moving forward. So just as a reminder here, let me do this one here, because I think it's going to, yeah, now let me write. So mu is 52 plus 1 standard deviation, so 1 times 2. And so here, 52 plus 2, it is not letting me write. So let me do it down here. Equals 54. So 54. So that 1 standard deviation, that was right here. All right, so with the rest of it, we're adding 2 standard deviations, adding 3, adding 4. If you were to finish working these out up here, finish working these out right here, the answers will be this. 46, 48, 50, mean is 52, 54, 56, and 58. So if you work them out, that's what you should get. Now, what we're asking for this problem is between 50 and 54. So between 50 and 54. Guys, this is really not letting me draw that. I don't know why. Between 50 and 54, we get that. All right, so with that, remember we talked about our percents also that came with this. And we said, okay, we know smack dab in the middle right here. Smack dab in the middle actually is the mean, and we cut everything in half as we go out. So here, this whole area, remember this was 68 degrees. Percent. That was 1 standard deviation was 68%. So if you look at it, 50 to 54 is actually 1 standard deviation, which is 68%. All right, so again, remember all your percents there. You had 1%, one standard deviation was 68%, two standard deviations was 97.5%. Sorry, 97%, and then three standard deviations was 99.5%. So that's where we got going on there. All right, so let's move on to number 2. And it says here, first off, number 1 was normal distribution. Normal distribution. All right, second one here is we have now, algebra tests, we have 5 multiple choice questions with 4 choices with 1 correct answer each. If you just randomly guess on each of the 5 questions, what's the probability that you will at least get 1 question correct? So at least one question correct. So we're talking about here 2 different outcomes that could happen. 2 different outcomes. So we can either say it could be correct or we can get it wrong. It could be correct or it could be wrong. So that's 2 different ways of happening. We know there's 5 different trials we're doing, 5 multiple choice questions. All right, they're independent of each other. If you answer one question wrong, doesn't mean you get all the questions wrong after that. Yeah, and so we're doing good here. So that, and all the probabilities of getting a question right is much as 4 multiple choice questions choices. And there's one of them that's correct. So the probabilities are the same for each question. So that means we're dealing with a binomial distribution. Remember, binomial meaning 2, and our 2 situations are correct or wrong. Correct or wrong. So we have those 2 things. We have the number of trials we have, which is 5. We have a probability that's the same for everything. So what we need to do here, since it's binomial, we need to find the n, which is the number of trials, and that's 5. There's 5 multiple choice questions here. The probability of getting it right, so P of x, let's say that, P of x. Probability of getting that right is going to be 1 out of 4 choices. So you get 1 answer that's right out of 4. 1 out of 4. So it's a 25% chance of getting it right. This is 4 choices, and there's only one of them's right. So 25% chance of it getting right. All right, so then they want to know what's the probability of getting at least 1 question correct. And so here, at least 1 question. Let me write over here. Let me. Somewhere will let me write. That'd be great. I'll put it up here, guys. I'm running out of space at the bottom. It's not letting me write. All right, so at least 1. That means everybody already knows 1 or more. So when we do our binomial distribution, that means we're going to start off with our min being 1 and our max being the maximum that we could have. So at least 1 question correct, but there's 5 questions in all. So our max is 5. All right, so when we put in the calculator, we're going to do binomial dist. This is going to be in Desmos. We put the n first, which is 5. Put our probability, which is 0.25. And then we put our max and our min and our max. All right, so let's go put that in there real quick. So let's go to Desmos. All right, so we said we're going to use the binomial distribution. And I'm going to just write this out so we can see it so that we can just type it in. Write it back out, I should say. All right, we said that it was actually 5 for the n. That's 5 questions. The probability of getting it right is 1 out of 4 or 0.25. And then your min and your max. Min was 1. Max was 5. So we're going to put that into the calculator and find that answer. Binomial distributions. All right, so from here, we're going to come here. The functions, go to dist. Now, in other words, distribution. We get 5, comma 0.25. Close it out. We're going to click on find cumulative probability right there. And we're going to put 1 here. We're going to put 5 here. Max and min and max. And that's our answer, guys. So you can either have it as a decimal, and depending on what the answer choices are going to be on the test and everything, it'll let you know. We're around at 4 decimal places. So here, Could be the decimal or it could be the percent. 76.27%. So it could be either one. So binomial distribution, yay! All right, so we're gonna do one more binomial distribution too, also, again. And then we're gonna go ahead and go to the last couple of questions. All right, so let's move on back to our questions. Preguntas. All right, so let's go ahead and take a look at this one. And I had some technical difficulties happening there, so let's get this bad boy. So it says the American Red Cross says that 11% of the U.S. population has type B blood. A blood drive is being held at your school. And what is the probability at least 2 of the first 10 blood donors would have type B blood? Sorry. So here we have 2 different possibilities. We have somebody having type B and then someone that does not have type B. So they're either type B or not. So there's 2 different types happening, 2 things happening. All right, so that means we have that. We know there's 10 people in all. So that's our number of trials that we're doing with. We know a percent, and we're trying to find at least 2. So with this, we're going to go ahead and look at our binomial because we know there's 2 different things happening here. All right, so our n is going to be 10 because that's how many people there are in all. That's how many trials we have. All right, when it comes to your percent, that's 11% or 0.11 for your percent. Again, that's your n, that's your p. All right, and then for at least 2, we already know what that means. That means our min is going to be 2. And if we say at least, that means it's going to be 2 or more. It's like the last problem said at least 1, so it means 1 or more. So here we're going to do 10, 2 to 10, and then we're going to put in Desmos, and we're going to go from there. So let's go to Desmos real quick. So we're going to take this right here and put in Desmos. And let me find Desmos. There we go. So I'm going to change these numbers here just real quick. So we said this is 10. We said this is 0.11. And we say it's from 2 to 10. All right, and we get that answer. Let's get rid of that part. So we can say that the answer is going to be 0.3028, or we can change it to percent and say it's about 30.28% chance of somebody having, at least 2 people having type B blood. So that's a good number there. That's a good number. All right, so cool. That's it. We got that. So we have 3 more examples left to do, and then we're done, guys. That's it.